in the cloud. So let me get started. So I have, this is the agenda. So I start with a quick background information, and then I go straight away, go to the basic solution. So the basic solution is using attribute-based encryption to perform encryption and access control. And the next two topics is to make the solution practical. So how to improve the efficiency of the system, so that even mobile users can benefit from the technology, from the system, and also to improve the privacy protection. Right. Well, before I prepared the slide, I just did a quick search on the web to find out what is the how large are the storage services in the cloud. So this is what I got. May not be up to date, but those are the information available from the web. Dropbox today has 300 million users. Large number. Microsoft OneDrive has 250 million users. And if we look at the Google Drive, just started 2 years ago. Right? Today it has roughly 200 million users. The iCloud 3 years ago with the largest number, 320 million users. So the demand for storage in the cloud is huge. It's growing very fast. I think that the reason is we are generating so much data, and we need a low cost and efficient, convenient way of backing up our data and access our data. Then the question is, so if we put all our data in the cloud, so essentially the service provider is capturing all the information about us. So how about data security and the privacy? Can we trust the cloud service provider to keep our data confidential? And if not, what are the solutions? What can we do? Here, a quote from this Professor Ravis. He's the person one of the three inventors of RSA, application encryption algorithm. So this is what he said: cloud computing sounds so sweet and wonderful and safe. We should just be aware of the terminology. So if we call it swap computing, I think you might have the right mindset. All right. Well, the Apple CEO Tim Cook, he said that if you get a free online service, you are not a customer. You are the product. So you think about it. So a lot of such cloud services are free. You think you are the customer, you get the free service, actually you're part of their product. Well, the recent incident on the Hollywood celebrity nude picture, right? I think this really heightened people's awareness on the cloud data storage, security, and privacy. But to me, this is only the beginning. So there are a lot of incidents happened in the past we do not even know, because the celebrities are reported, and many such incidents will happen in the future. So security becoming a very important issue. Now, so what is the root cause of the security and the privacy issue in the cloud computing? The root cause is that in all those services, they follow the traditional access control model, the computer security model. So in that model, within the rectangle, let's say that is the computer system or the cloud system. So under this access control model, we have to trust our service providers. So we have to trust our service provider to perform access control. So that only the legitimate user can access the data. And we have to trust the service provider to keep our data confidential. So those are the two trust assumptions. The third assumption is that under this model, we have to trust the users to handle authentication correctly. Right? So a lot of trust assumptions. Well, talking about the user, the authentication, the Hollywood Milk Picture incident is because of a break-in into the authentication system. Authentication system normally is the weakest link of the security system. You use a common password, you use a low entropy password, or use the same password at many accounts. So those has been a huge problem, headache for the security professionals. The other thing is that the trust assumption in the existing model is not realistic, because the cloud computing hardware is not under our direct control. May not even under direct control of the service provider. And software has bugs. Even the service provider has good intention, it may cause security problems. And the other thing is that our portable devices can be lost. So you lost your data, you lost your devices, the data could be lost. And moreover, sometimes we have the insider attack. There was an incident. Google, one of the employer of Google, not happy with the organization when they exposed users, customers' data. So that model is not realistic. So what is a good model in the cloud storage? Well, this is the ideal model. The ideal model is that we assume the service providers are untrusted. So we don't trust the service provider at all. So we don't trust service provider at all in the following sense. We don't trust service provider to keep our data confidential, because they may mine our data. So why the service providers give you the storage service for free? Because they are doing data mining. Right? They get a lot of your information they can sell to the third party. Right? They will not run the operation at a loss. So we don't we don't assume they are capable or they have the intention to keep our data confidential. This is one. The second one is that we do not even assume the service providers to perform access control correctly on our behalf. So this is we don't trust the service provider at all. This is the assumption. But under this assumption, if you think about it, the only solution is to have encryption, to encrypt your data. So when the data is on my computer, I can encrypt text. When the data is in the cloud, I encrypt my data. So the cloud only sees the ciphertext, encrypted data, not plain text. So I don't trust you. I don't, service provider can disclose my data. Random garbage. You can, it's not plain text. It's fine. It's okay. So only when the data, once I access the data, only data comes to my computer, I perform decryption. So encryption is the only solution under that assumption. We do not trust the server. And the encryption actually is a good practice because in security, there are many, many security principles. One of the principles is defense in depth. So even if I trust my server, my storage systems, it may be broken, maybe due to bugs get hacked. So when that happens, I have encryption to protect my data. So this is the principle of defense in depth. Now, so I hope I made it clear the importance of data encryption in the cloud. And the second point I want to talk about is when we have the encryption, right? We have to access our data. We have to share the data with other users. So what are the technologies available of doing this? So if the data encrypt is only for yourself, the solution is very easy. You just install software on your computer, encrypt, decrypt. But we want to share our data with others, maybe with the colleagues in the same organization or with friends. The traditional approach, we have public key encryption, we have symmetric encryption. Symmetric encryption is a secret key that we share between the parties. A lot of overhead, potentially. We don't talk about symmetric encryption. But even for public key encryption, it also is not scalable. Yes, it provides a solution, but not scalable. You must have scalable solution. You cannot use a one-to-one encryption. Public key symmetric or one-to-one encryption. I perform the encryption only for one user. If in the organization I have 1,000 users, I want them to access my data, I must perform encryption 1,000 times. The other problem with public key solution is always public key certificate management. Many issues. SSL is not secure because of the certificate management. We don't have a good management solution. We don't have a decent public key infrastructure. So the wish list for storing encrypted data in the untrusted server in the cloud are the following. So we also have key management, which is scalable and offline. So don't have to have an online server to support key management. And we do not want to have an online trusted party to perform access control on our behalf. So hopefully we can have an encryption technique which has built-in access control capability, built into the mathematics, instead of a third party performing access control. And lastly, we want the access control to be expressive. Expressive means I can express my policy. I should have, certain flexibility to express my policy. Well, the answer. This is the recent progress in the crypto community in the past 7 or 8 years. In the crypto community, there are many new algorithms invented each year, but attribute-based encryption, in my view, is one of the practical and useful solutions. So, for example, this attribute-based encryption has been used in the Johns Hopkins Hospital experimental system to protect patient's electronic record on the cloud, so that doctors or the medical researchers can access data based on certain security policies. The attribute-based encryption, there are two forms. So I just mentioned this one form, which is called ciphertext policy attribute-based encryption. So here is how it works. The data owner, when he wants to upload his data in the cloud, he performs the encryption of the data. And at the same time, he attach the access policy to the data. So this is access policy. So this is the enlarged version. This can be a tree structure, can be a matrix, can be in many forms. So this policy, this is just a toy example. For example, A could be a professor. B may be a PhD student. C can stand for computer science department. So this policy says if you are a professor, you can access decrypt my data. Or if you are a PhD student in the computer science department, you can access my data. Of course, you can attach many other conditions. Now, when the ciphertext policy are uploaded into the cloud, the cloud, we treat cloud as a storage, that's all. Now, we need a so-called key authority, which is offline, which issues decryption key for the users. So we have, let's say we have 3 users. Each user will have a set of attributes. So for example, this lady will have the attribute professor. So the key is attached, bound to the attribute professor. And the second person is a PhD student, has a key. The third person is a student in the CS department. He also has a secret key. Now, only when the user's attribute match with the security policy, he can access the data. So this user has attribute A. This is A. This means all. And so then he can access data. The second one, his attribute cannot match with the policy. He cannot access data. The third person, attribute match with B and C, he can access data. So this is the beauty of attribute-based encryption. You do not, when you perform encryption, you do not have to know each and the individual potential users. You just describe your access policy based on the user's attributes. So in that sense, it is very scalable. Now, the next question is, a lot of cryptographic techniques are very computational intensive. Needs a lot of computation, especially public key-based solution. This is kind of public key solution. So the next one, our research is that we try to improve the efficiency, to make it practical. So how expensive it is, attribute-based encryption. The attribute-based encryption can, in the policy, can support arbitrary number of AND and OR and key out of unthreshold gates. So this tree can be very large. So it can be very large. For example, it can support integer comparison operations larger than or less than or equal to. But when you support this integer comparison, for example, if we have a Unix time, my key must be the expiry time must larger than X. So this condition can be expressed in the access control policy, but not as one node. Unix time is expressed in 32 bits. And if we support this, our tree will have additional 32 nodes. So you have 2 times larger than or less than, you will have additional 64 nodes. Now, attribute-based encryption, the underlying operation is called bilinear mapping, which is very expensive, even more expensive than RSA. So, if we have, suppose we have a policy with 100 nodes in a mobile device, we did the experiment. The decryption will take 40 seconds, which is definitely not acceptable for users. So then the question is, how can we improve this efficiency to make it acceptable? One of the possibility is that how much time do I have? I want to
please go ahead.
Okay. So one of the solution is for the user, your data encrypted is in the cloud and have this secret key to perform decryption. Maybe I send my secret key to the cloud, ask the cloud to perform decryption for me. Right? Then I don't, there's no performance bottleneck at the user device. The problem is we don't trust the cloud. Cloud perform decryption will have access to our data. That defeats our purpose of encryption. So the one solution proposed by this group of researcher, Waters, this professor invented attribute-based encryption, is to use a so-called ADE with out-source decryption. So with decryption, out-source decryption computation to the cloud, but the cloud will not get our data. You perform decryption on my behalf, you cannot access my data. That is ADE with out-source decryption. So the technique works as follows. The ciphertext stored in the cloud, and each user, instead of one secret key to perform decryption, each user is given a transform key, TK, and a decryption key. So each user is given this 2 key value. The transform key is public information. Right? The decryption key is secret information kept by the user. So when the user wants to perform decryption, he has to send his transform key to the cloud. The cloud will perform 99% of the computation, but without getting the data. After the computation, a much simplified ciphertext will come back to the user. The user only performs one step of the operation to access data. But that solution has a limitation. The limitation is that maybe the cloud can cheat. I ask the cloud to decrypt ciphertext A. The cloud really decrypts ciphertext B for me. Maybe the ciphertext he decrypted before. He just replay that ciphertext. So there is no guarantee the cloud perform the correct operation. So what we did is we improve that technique. We can guarantee, the user has guarantee that the cloud computation is indeed correct, is according to our requirement, our wish. And so here's the performance. Without out-source decryption, this is the normal one. The red curve is using a PC to performing decryption. So if the policy has 100 nodes on the PC, it will take roughly 4 seconds to perform decryption, too slow. On a mobile device, this is a Samsung device, will take more than 40 seconds to perform decryption. But if we use the after source decryption technique, most of the operations are performed in the cloud. Cloud cannot get our data. Only the last step is performed by the user. Then we can improve the performance on the user device tremendously. So for PC, it will take less than 0.02 seconds. Even on a mobile device, it will take less than 0.2 seconds. So the solution makes the system very, very practical, can support PC users and the mobile users. Let me skip this part and go to the next problem. In the attribute-based encryption, you perform encryption and attach with a access policy. An access policy and your ciphertext are uploaded to the cloud. That is how it works. So in this example, maybe this is an electronic medical record.
10 more minutes.
Okay, all right. Maybe another 10 minutes, 15 minutes, 30 minutes. So this, the data is encrypted. It's accompanied with a policy. This policy is attached to the ciphertext. But in this policy, because this is an electronic record, this policy says somebody with such a national identification number can access decrypt my data. Maybe this is the patient himself, or any cardiologist at the university hospital can access data. So this is also where the scalability of ABE comes from. So you don't have to specify individual users. You can if you want, but you don't have to. You just say any cardiologist in the hospital can access my data. Now, on users, let's say we have user 5. He has this identification number. He can access the data because this is one node is enough. User Alice, she is a cardiologist at university hospital. She satisfies this condition. She can also access data, but not other people. But the problem is with this access policy, your data is encrypted, but access policy can leak a lot of private information. So using this example, so we look at this policy, then right away we can infer this person with such an identification number may be suffering from heart problem. Right? Because this is a heart doctor. So the access policy, data encrypted, access policy not protected, leak a lot of information. That defeats our purpose. Then the question is, can we hide our access policy? We attach the policy to the ciphertext, but the details of the policy are hidden, not in clear text. So there are research efforts on this to completely hide your policy. So, for example, you can have the ABE with fully hidden access policy using in the product predicate encryption. So this is one solution. All right. Then, if we use this solution, it can support access policy written in CNF and DNF form. CNF is conjunctive normal form. So it means you have the X and B and C, etc. And disjunctive normal form A or B or C. Right? But the problem is using this solution, your policy will become very long because the super polynomial grow up in the size of the formula. So one is the policy become very, very complicated. The second one is when the policy is totally hidden from the user, how do you perform decryption? The user have to try every ciphertext one by one, which is very, very time consuming. Because the policies are hidden, you have to try every ciphertext policy. Not efficient. So what we propose, this is a paper published 2 years ago. What we propose is that we use attribute-based encryption with partially hidden access policy. So instead of completely hide your access policy, we do a partially hidden of the policy. This is access policy. And for what we did is, for each attribute, we divide your attribute into a name of the attribute. For example, this is social security number, right? And a value. So this social security number has value, has this value. And for the second attribute, we have the name, the value is university hospital. For the third attribute, name, occupation, value, cardiologist. So by doing this, and in the policy, what we do is that we only release the structure of the tree and release the name of the attribute, but the name of the values of the attribute are hidden. So if this is published on the web, together with the ciphertext, but disclose very little information because names are generic, values are specific. So it's only when we reveal the values we need to disclose private information. So this idea, we publish this with the name without the value. So the next question is how to do this, how to make it possible. This chart shows the attribute-based encryption, how a ciphertext looks like. So we have the access policy like this, and this is our encryption. This is our ciphertext. This is how we do the encryption. So what happens is, here's the message. The message contains this term. All right. And now after that, we have 1, 2, 3 more terms. Each term corresponding to a leaf in the access control tree. So for this, we have this component. The second attribute, we have the second component. The third attribute, we have the third component. So if you have 100 nodes, you're going to have 100 components. So this is the one without having the value of the access policy. So how about we don't change anything? We just use the same encryption technique. We just erase the values. This is a simple solution. The problem with this solution is it's subject to dictionary attack. So in security, what we always say is that you must perform a formal analysis. Intuition can be dangerous. So intuitively, this is the solution, but it's not secure. It's subject to offline dictionary attack. That means if given the ciphertext, given the tree, the attacker can try different values of the attributes until he gets the correct value. All right. So this solution, straightforward solution, doesn't work. Now, so what is the correct solution? I'm not going to go through the details, right? But just tell you the underlying technique. the attribute-based encryption, the mathematics is bilinear mapping. All right, it's bilinear mapping. So bilinear mapping has this two properties. So this is one property, and this is second property. This property means that we have two input elements. After mapping, the exponent goes to outside of the mapping. The second one says that the mapping will not make our target smaller. So if your input has this many elements, after mapping, it preserves the number of elements. It's not degenerative. And the other property is this is a group with composite order. Means it has prime element factors. So if we take the subgroup on the input, we take this as one subgroup, this element from one subgroup, and another element from another subgroup. Then we do the bilinear mapping, we have the identity element. So in our construction, we use this orthogonality property to defeat dictionary attack. Because this is not a security conference, I will not go to the details. All right. So, but there are solutions available. So in the end, so what we get? So this is just to summarize how the system works. So using the attribute-based encryption for the cloud storage, the user encrypt the data and in the same time generate a access control policy. So this policy only has the name of the attribute without the value. Values are hidden in the ciphertext. And the potential users, each one has a set of attributes, and they also have a secret key corresponding to the attribute. If the attribute satisfies the policy, we are able to decrypt the data. So because of that feature, there is no need for access control in the cloud. You access the ciphertext. If your attribute is correct, you can access the data. So the access control is built in. And to improve the performance, we can also let the cloud to perform 99% of the computation. The user only perform one last step to improve the efficiency. Okay, that is the system. We have the solution. Now we are in the process of making it a prototype, operational prototype. So to summarize the talk, existing access control model in today's cloud storage, assuming the service provider is trusted, assuming the users is able to perform correct authentication. So our solution is we get rid of all the trust assumptions. We don't trust the cloud at all. The cloud service provider, we don't trust you to perform access control. They don't trust you to keep our data confidential. Some of the service providers today, they do encryption. They upload their data, it's encrypted, put into the hard disk. The difference between their solution and our solution is that the cloud service provider has the key to decrypt. So any time he can decrypt your data and do the data mining. So in our solution, user has the key yourself. You can delegate the decryption to the other users by the access control policy. So user has the complete control instead of the cloud service provider. Using ABE, we can make the system scalable. You can have a large organization. For example, in the hospital environment, when you perform the encryption, you don't have to know each and every individual users. You just specify in terms of attribute. And the system is also very efficient. Even on a mobile device, can perform decryption in a sub-second. And privacy preserving, the policy may need private information, and that information they also want to block. So the policy will not leak private information. The ciphertext is secure, encrypted, will not leak any confidential information. Lastly, just some of the research work, because this is not security conference, the research work may not be interesting to you. So I think one of the interesting research work is how to automatically generate your policy. So when the user performs encryption, you do not want the user to specify each leaf of the tree, manually. So you want to have a tool automatically help user to do the policy generation. That might be interesting research. Okay.